Hello, everyone. Thank you for coming to my talk. I hope you won't be disappointed by my bold title, that I will fix everything with design Python. I am a freelance engineer. I'm working for research lab. I'm developing new software to help them with their experiments, their data analysis. And I'm French, so sorry for the accent. This talk I already done 2 times in research conferences. So this time it's a bit different because you are coming from a different background. And the idea is to do a walkthrough how I'm taking a new project with a new lab. So how I can see that the software is a bit a mess, because when they call me, it's a mess, and how we can refactor it to make it more usable, customizable for the researcher. I know the academic world is a bit different than the industry, but I hope it can give you some inspiration. So first, how many are coming from the academic world here? Nice. And we have more and more discussion about research software engineering and not only the researcher doing everything. So I hope you can go in this world too soon. So first, I want to tell you how a software is created in a research lab. It's a story I met multiple times in different labs, and I've been discussing with a lot of people, so I think it's something that resonates. Usually, it's, so we have Hannah, she can be a PhD, a postdoc, or a PI in a lab, and she loves to program at the same time as she's doing her own research. She likes to program to automate tasks, having better experiments, gather more reliable data. And her teammates find her software very useful, so they want to use it. Anna, she's a good teammate, so she shares the software. Everyone is happy. But then, George needs a small modification, because his experiment is a little bit different. So Hannah, at the same time she's doing her own work, she's doing the small modification because she's nice. Then James needs a small modification because his experiment is also different. And you see where I am coming. Then we have Luca, which needs a small modification. And very fast, this is Anna. So at this point, we can say that the software is born. What happened in a research lab? Either the software is enough big, enough interesting, the lab has money, then a specific team is created to manage it, share it. They have their own time to work on it, their own resource. That's a good path. Or most often, Anna stays the sole maintainer, and she's doing the modification on her free time. Because it is on her free time, she's doing it fast, she doesn't maintain it very well, because she has to do her own research on the side. So very fast, the software multiplies in 10 different versions on each computer in the lab, because one needed some hardware on one computer, another hardware on the other computer, and nobody takes the time to merge everything. Or, on hand, Anna leaves for another job. So, and nobody knows how to install the software anymore. Usually, it is at this point that I'm coming in the lab to help with this problem. And the first thing I do is to look at the good practice. This good practice didn't exist in research a lot before, but now there is a big push to use them. So I look if there is Git, if there is documentation, if there is a pipeline for tests, for formatting, stuff like this. The usual thing we are all using, I hope, and if not, do it. But it's not enough to ensure the software will stay clean. So to do that, we need especially in research domain, we need a modular software because like we saw in my little story, each experimenter wants the same software, but not exactly the same because they have their own experiment, their own business logic. So the developer responsibility is to first discuss with every user to see what is the common business logic and what are the particularities for each one. Then you need to think about what will be the infrastructure, logging, output, stuff like this, and separate it from the core, the business logic itself. Then we try to push to everything which is input or output, hardware, driver, stuff like this. We put it on the system edge, on the software edge, to have a clean business logic model at the middle. Once we have this, we can start to think how we will make certain parts customizable for the user and other parts fixed. So to do that, we will take an example that I often encounter in a research lab. The little GIF is an example of a very old software I developed, which is in the same idea. So the research software we want have different hardware that depend from which searcher we use it. So it can be Arduino board, camera, everything. And it needs to be customizable. Like this, each researcher can say, okay, for my experiment, I want to use this camera. I want to use this Arduino board, but not this one and not this one. The experiment on itself is applying different stimulus and gather data from it. This stimulus and the algorithm behind will change depending on the researcher. So we need to have this part customizable too. We also want to have a nice GUI, which should be fixed. Like this, one researcher can explain to the other researcher how to use it. And we want login management, test, the user stuff. And we really want the power user, the researcher, to be able to customize his experiment without touching the other stuff. So ideally, a new researcher would say, I will use this software. I want to specify what is my experiment in a config file. I want to describe my experiment as a Python code in one part, put it inside the software, and it works. That's the idea behind. To do that, we will use the design pattern. So how many from you know about the design pattern? Okay, that's good. Yes, the design pattern is an old concept from 94. It's from, we often say it is the Gunner 4 that wrote it. There is 23 design patterns. They are not all suitable for Python, so if you read the book or read information about it, keep an open mind on it because it's not all for Python. And we won't talk about the 23 today. That would be really too much. We will talk about these 3 ones that I'm often using in my software. And first we will start by one. I didn't see it in the other slide because it's not funny. The MVC pattern. So for those that come at the first, at the EVNEC presentation Wednesday, he said the model is used for so many stuff, we don't know what it means anymore. So in that case, the model view controller, model means your business logic, the core algorithm. Then at the middle, you have the controller, that will be the backbone, the glue, it will take everything and allow them to discuss together. And we have the view for the user interface. A quick talk about the GUI. You can use as many frameworks you want with PyQt, with web. There is some example here. If you want to know if you have a good MVC, it means you can switch from a GUI framework without changing the rest of your code. If your controller is doing the right abstraction, you can change your GUI in very fast. Then you have the controller, which is the backbone that glue everything, like I said. It's really at the centrum. It will take the configuration at the start and decide what type of experiment the user wants, what type of hardware the user wants, and so on. So that's really at the middle. Now the interesting thing, how we can architecture the model to have this kind of customization. First, we will think about the abstract template pattern. So first, you take the different customization parts you want, hardware on the side, algorithm on the other, experiment algorithm on the other, and you will write a parent class that will describe how you would like your experiment to go. So you have a create experiment, a function which is common for everyone, and that will allow to create the experiment, so logic. And then you put your step 1, step 2, step 3, and it is the user that will create his own class, child class, and that will be able to specify in function the different steps of your experiment. This is very practical from a researcher point of view, because he doesn't need to know anything about the software, just need to know you have step 1, step 2, step 3 to fill. And you put it in a file and put it inside the software. But now, how we will link this new class he did with the rest of the software. To do that, we can use the dynamic factory registry pattern to link the right experiment to the right hardware. So we have a registry class that will decide which experiment to call. And in terms of Python, how it looks like, in input, we want to have a config file where the user says, OK, I want this experiment, I want this hardware. And then the registry take it, read it, and create the experiment. Once he has the class experiment, he can just run it. To do that, there is multiple techniques. There is the first one, the dictionary technique, where we say a keyword that will be in the config file, and we link the right experiment in front. But the problem with this one, so this one is good because it's very clear what is in the software. But from a researcher point of view, he needs to go inside the code to modify it, to add his own experiment. While I said that a researcher likes to just fill a Python file and put it in the software and do nothing else. So to do that, you can use the get attribute and callable function. So this, you will have your experiment in a folder, and you will look inside the folder what is existing. So as it is at runtime, it will look at runtime what is existing, and link the name of the experiment and the keyword. It allows you to load at runtime a new experiment. The little problem with that, it means in the config file you cannot put a quick keyword. You need to put the path, module, and the class name, which can create error. There is a third solution, but I won't describe them all using a decorator. So it's really up to you to use the one you want. Okay. And then you have the manager logging, so that is quite easy. I'm guessing everyone uses the logging Python library. Did you know that the logger object is a singleton? And so that means when you call a logger with a name, so if you use the root name, it's just an empty string, like here. But you can also name your own logger. You should also name your own logger. This will create only one instance. And each time you do a get logger, it will look inside the dictionary in a manager, logging manager object to return the right object. the right instance. I also advise you to custom your handler. So the typical one are to stream your logging across network. Me, what I like to do is to display in a PackUT GUI the log. Like this, the user can see them in real time. And to do that, you need to write the logging handler class, like this. And congrats, you got the software. So, yes, it's a bit big, but it is exactly what we described until now. And I have no idea why I was so fast. So, sorry. We will have so many time for the question. I'm very happy. So just to conclude, do use the design pattern to sync your software before programming it, because it will help you to keep a clear separation between what is business logic and infrastructure logic. Keep a balance between flexibility and giving space for the power user to custom your software, but keeping control. One of the examples is here we talk about giving control about what kind of hardware, what kind of experiment we have. But sometimes I am asked to have flexibility also in the data output. That's a very bad idea. Very fast in the lab, you have like 3 different formats for the same data for the same software. So this one should be only one and impossible to customize. Even with the best practice, the software needs maintenance. So if you don't have research software engineer in your lab, hire one. That's it's the best way to keep the mess out. Okay, do you have a question? Yeah.
Thank you so much for a very insightful talk. So do we have any questions? All right, and just in case there is also a standing microphone.
Thank you for the talk. It was very interesting. I would like to ask about the factory, because I didn't quite understand, because you are loading the classes dynamically, right?
So
yes, this one on the right side.
Yeah, here.
So you are loading them from Python files?
This one, yes. So get@ is a function that look inside a package. So here the package is trigger. Okay, I could have put experiment.
The scientist just adds a new Python file or
yes,
or a class with the logic, and
yes.
it gets loaded.
So your scientist create his own Python file, you put it inside the module, which is called here trigger, and then when you want to look at it, you have the keyword, which is the name of the Python file and the class, the name class too, and you look inside the package. For this one, it will load the class, which is callable, and then you can run it like this. Once you have it, you can just run it.
Thanks.
Some more questions?
Why do you have a core class, and how do you do anything special to keep it from becoming a God object when other people start fiddling with it after you're gone?
The core class, you mean the model or the controller? This one?
Yes, that one.
This one normally the user doesn't add anything on it. It's just the maintainer that we need to move stuff to add new object if they need. So what exactly was your question, sorry?
When I've worked in projects that have things like a core class, I find that people tend to put more and more things in it, like, oh, this is the application class, so I need to put this in it and this in it, because these are all part of the application, right? And then, it becomes a big unwieldy class. instead of having discrete objects that only know about what they need to know.
Yes, I agree. It happens, definitely. Me, what I'm doing is I'm creating subcontroller. So we have one main controller that runs everything, and for each domain, so again, hardware on the side, experiment on the other side, I create another controller that manages it.
Thank you. Any other questions?
So when you're working with scientists, they are not computer scientists. They are not used to working with these elements. How do you get them to actually use all this stuff you set up for them? Like, how do you educate them on your framework here?
There is two types of people in the lab that I educate differently. The one that doesn't really want to learn Python and they just want to be able to use it for the experiment, I am very, I tell them just modify this file, that's all. And like this, they don't need to care about the rest. That is the advantage of a structure like this. And there is the other ones that want to learn about Python. In that case, but I'm doing a bit like this presentation. I'm explaining, I'm doing often workshop also to explain design pattern, Git, stuff like this. Because it's often in a one-to-one or one-to-two, it's working well, I think.
Thank you for the talk. And I want to follow up on the previous question. So like you mentioned that sometimes you like have like these workshops. Don't you think it's sometimes maybe hard to grasp for some like newcomers for like to Python, like this kind of like structured objects and design patterns? Because yeah, that's the question.
Yes, definitely it can be hard for people that are not at all in the domain. I think you need to go where they are and start slowly to improve their knowledge. So I won't start with class when they don't know basic scripting, for example, or Git. I really start with the good practice first, and then we improve. Having an example on is helping also. It's really a long-term goal.
I have another follow-up then, like, how about then just creating some kind of wrapper for this whole structure, like to completely encapsulate this like complex structure from actual, I know, some 2, 3, 4 functions that like researchers may use without really going into it. Like, do you think this is like a kind of feasible solution in this case?
I am often asked that. Me, I don't think it's a good idea to do a big encapsulation like this because you lost in flexibility. Because a software like this works for one lab, but it won't necessarily work for the lab, the next lab. And your researcher scientists like to be independent, I would say. And they like to be able to go in the code and modify what they want and so on. So I'm not sure having a framework will work for that.
Any other questions? All right, then. I think if you come up with more questions, then you can continue on Discord or via social channels. And let's give roaring ovation to our presenter.